Assalamu alaikum, dear students. So we continue our work with quantum mechanics. It is part 2 of lesson 3.2 photoelectric emission of electrons. Again, it's part 2. In this part, we will concentrate on Einstein's equation and the derivation of Einstein's equation, and we will apply, we will solve some applications on photoelectric, on work function and on Einstein's equation. So most of this video will be practicing on, after deriving Einstein's equation, practicing on these equations. Okay. To understand the equation, or from where this equation comes from, Einstein used the idea of conservation of energy. Conservation, using the conservation of light energy, or energy in general, which is used in the experiment. Understand me more, I will give you example. If in the experiment we have done, just to make things easier, this is the light, which comes, the photon which comes from here. Imagine it has 6 electron volt energy. This is the energy of the used photon. And the electron which is on the surface, or the metal, has work function 4 electron volt. Means this electron, to leave the metal, it needs how much? 4 electron volt. So this energy, which considered as a total energy, part of it will be used to remove the electron, which is how much? 4 electron volt. What's remained from 6? 2 electron volt. It will be used to move this electron very fast. So the remaining 2 electron volt energy, which is considered as maximum kinetic energy, will be used to move the electron very fast. So if we concentrate at the whole process, we see the 6 electron volt is divided into 2 main parts. Part is used to remove the electron, which is the work function, and the remaining part, or the rest part, is used to move it very fast with 2 electron volt. So I see this equation shows the conservation of energy. So 6 will be equal to 6. This is the concept with which I will derive it here. The concepts of Einstein's equation. So using the conservation of light energy, we can write that the energy of the photon, like the example I gave, will be equal to the energy used to remove the electron, which is work function, plus the kinetic energy maximum used in moving it. You see? So this formula, it's something we understand. No need to memorize. Is it clear? So a photon considered as the total energy is divided into 2 main parts, the work function and the maximum kinetic energy. This formula, we can deform it. It depends on the given and the required. Is it clear? We can replace E photon by HF. We can replace the work function by HF threshold. It depends on the given. If the given is F threshold. And we can replace kinetic energy by half mv square. Akid. This m is the mass of the electron, because the electron is moving, and this speed is the maximum speed of this photoelectron. You understand? If I have the wavelength for both, we can, instead of using frequency, we can write hc over lambda equal hc over lambda threshold plus half mev maximum square. So the used formula, you can deform it, you can change its form according to the given you get. In some textbooks, the previous textbook, they were using it like kinetic energy, making kinetic energy the subject. Kinetic energy maximum subject is equal to E photon minus the work function. Same idea. Is it clear? If you understand like what I told you, that this example, it's very important. Simply you understand the formula. So no need to memorize the formula. The formula will be given, already will be given. We can understand it as conservation of energy, and we can, if you want to memorize, you can memorize, but it will be at the end of the day, it will be given. Okay. And as you see here, we see exactly what we derived before. So E photon for the incident light, it's the work function plus the maximum kinetic energy for photoelectrons. So E photon equal work function. So this is now we see the formula is very clear for all of us. Now we can start solving questions and apply Einstein's equation. Okay. Let me read together and practice together with starting with question number 1. A metal has a work function 4.5 electron volt. So he's giving me the work function. So the work function is given. The work function is given as 4.5 electron volt. Okay. What is the maximum kinetic energy? We need the maximum kinetic energy for the electron, ejected electron or emitted electron, if the wavelength of the incident light is given. So the wavelength is given. How much? 2.5 times 10 exponent minus 7 meter. So keep in mind, when we need to solve any questions related to Einstein's equation, we have 3 main factors: E photon, work function, and kinetic energy maximum. You see? So he should give me 2 factors, asking for the 3rd factor. Here, work function is given. The E photon is not given, but he gave me the wavelength, so I can get it. You see? So it's very easy to find kinetic energy. Every time he gives me 2 factors asking for the, in most cases they do like this. So what we are looking for to find kinetic energy. Let me work together and see what I will do. So kinetic energy, I need kinetic energy, will be equal, make it subject, E photon minus the work function. E photon, it's hc over lambda. Because I don't have E photon, I have the wavelength, so I replace it according to the given. Minus the work function, it's already given in electron volt. And here we have a trick. We need to know this trick. It's very important. That this formula, let me change the color. This formula, you see this formula? This formula gives me joule. And this given, it's an electron volt. So we cannot subtract electron volt from joule. Here, be careful. Most students, they do this mistake. This formula gives me what? Joule. And this formula, and this given in electron volt. You need to have either both of them electron volt or both of them joule. Otherwise, my work will be wrong. So here he didn't tell me what I do if I needed an electron volt. So I have the right to do anything. I can change this to the joule or change this to electron volt. So what I prefer to do to change this to joule, to electron volt. So electron volt with electron volt, I get the answer. Even if you change this to joule, it's okay. But I see here the answer key in electron volt, so I prefer to change to electron volt. Let we work together. So here, 6.63 times 10 to the power minus 34. All of us know h is constant, will be always given. 3 times 10 to the power 8 divided by the wavelength already in meter, no need to change it. 5 times 10 exponent minus 7. So again, this answer in what? In a joule. You see? To change it to electron volt, you divide by E. You divide by 1.6. So here you add down times 1.6 times 10 to the power minus 19. So the answer will be here in electron volt. In what? In electron volt. So what you see, when I divide by E or by 1.6, the whole thing divided by 1.6 times 10 power minus 19, I'm changing, remember, from joule to electron volt, divide by 1.6 times 10 exponent minus 19. I told you this before, divide by E. So now the answer of Hc over lambda, it's in electron volt, minus 4.5 electron volt. Now I have electron volt and electron volt. If I write this on calculator, I will get 0.47 electron volt. This is question number 1. Okay, let me do another question, another application. Okay. Another question here is a question number 2. When light of a frequency, so if the frequency of incident light is given, let me write the given the other side. So it's giving me the frequency of light. It's 8.6 times 10 exponent 14 or power 14 hertz. And he's giving me the maximum kinetic energy for the emitted photoelectrons is 0.5 electron volt, asking for the work function, and he needs the answer in electron volt. Okay, so he's giving me 2 factors of Einstein's equation, asking for the 3rd factor. So again, what's Einstein's equation? E photon equal the work function plus kinetic energy maximum. So the work function, let me make it subject, will be equal E photon minus the kinetic energy maximum. So again, don't forget, I need the work function in electron volt. E photon, he didn't give me, he gave me frequency. Don't forget, this gives me joule. You see how much I'm concentrating on the unit? So HF and HC over lambda, they give it joule. And at the same time, he gave me kinetic energy in electron volt. I can't subtract or add joule with electron volt. You see? The joule, you can't subtract it or add it with electron volt. The units should be the same. The answer, I need it in electron volt. So I need to change this to electron volt by dividing it by E, like what I did before. So the work function will be equal 6.63 times 10 to the power minus 34 times the frequency 8.6 times 10 exponent 14. I divide, because if I keep it like this, it will be joule, divided by 1.6 times 10 to the power minus 19. So the answer in electron volt, minus 0.5 electron volt. So if you get the final answer in calculator, it will be approximately 3.06 electron volt. Okay? Another question. Till now, as you see, this is direct application on Einstein's equation. We didn't solve any reasoning question. This is considered as a direct application. Not direct, it's application, normal application question. Okay. Now, what I remember, this question is from the past paper, or identical to one question of the past papers. In question number 3, if a laser green light with a wavelength, so he's giving me the wavelength of the used light, is shone on the surface of all given metals. So I have 4 different metals. From which of these metals electron will be ejected? Okay, let me understand more. I have 4 different metals. Sometimes, okay, you need to draw to imagine to understand more. This is the secret of physics. To understand physics, you need to draw. You need to draw. I have metal A, metal B, metal C, metal D. When we say different metals, it's very important. Different metals, it means different work function. Different what? Work function. Different threshold frequency. different threshold wavelength. This is very important. And at the same time, I'm shining in all of them with the same. Imagine here I have light source, okay, and I'm lighting on all of them from the same source. You see? Okay, but from some of them electrons is emitted, some of them the electron not emitted. So when I say same source, it means same energy photon, okay, same frequency, same wavelength. You get the idea? So I have different work function. Okay. To understand what I will do here, I need to go back to the previous explanation to remember the condition. So the conditions we had before, to have photoelectric emission, the kinetic energy, the energy photon should be either equal or greater than the work function. Otherwise, we do not have photoelectric emission. So here we can compare E photon with work function, frequencies together, or wavelength together. In this question, you can solve it, and you take 10 minutes. You can solve it using 2 minutes. Okay, only during 2 minutes. It depends, and all of these ways they are correct. But he gave me the threshold frequency for all metals. You see, the threshold frequency for all metals are given. So simply what I do, from the wavelength we have, I find the frequency of light used, or the frequency of photon, C over lambda. If I know the frequency of light and I know the threshold frequency of all metals, simply I compare and I decide from which metal the electron will be emitted. Because electron is emitted when the frequency of the light is greater than or equal F threshold. So to decide from which metal electron is emitted, you need to compare either F with F threshold or lambda with lambda threshold, okay, or energy photon with work function. Is it clear? So here the easiest way is to compare what? To compare frequencies. So what I will do, first step, I calculate the frequency of light used. It's equal C over lambda, which will be 3 times 10 exponent or to the power 8 divided by 5, 4, 6 times 10 to the power minus 9 because it's nanometer. So the answer will be, let me do it on calculator to check the answer of